All right, we're going to take some notes about looking at the greatest common factor of your examples for your work tomorrow are trinomials, but this will apply to monomials, binomials, trinomials, whatever you've got going on. So before we start digging into polynomials and looking at greatest common factor, let's refresh and look at just some numerical examples. So we've got, what is the greatest common factor of 21 and 28? So we've got to look at both of these numbers separately. And what we're going to want to do is prime factorization. Is what can we multiply to get these numbers? And so that all we're left with are numbers that can be multiplied by 1 in themselves. So if we're looking at 21, we all know we can multiply 1 and 21 to get that. But is that the only set of numbers that we can multiply to get 21? No. We can multiply 3 and 7. So for 21, we're going to have up here that we can multiply 3 times 7. I'm stopping there because the only thing we can multiply to get 3 is 1 and 3. The only thing we can multiply to get 7 is 1 and 7. So there's no point in continuing our factor tree any further. So then let's look at 28. What can I multiply to get 28 other than 1 and 28? Well, I can multiply 2 and 14. So 2 is done because I can only multiply 2 and 1 to get 2. But 14 I can continue to factor out. What can I multiply to get 14? Well, I can multiply 2 and 7. So that means to get 28, my prime factors are 2 times 2 times 7. So what is the greatest common factor, or the greatest factor that they have in common? That is 7. So we've got to start thinking like this for all of our numbers, and then we'll look at how we handle the variables. So this is very much like a problem that you'll have for your assignment, and it is a cubic trinomial. So we've got to start looking at what are the greatest common factors. Well, I have 32x cubed, so I'm going to write it out this way, and I'm going to have a line. And then I've got 12x squared, and I've got 40x. I need to move this. Let's move these down so that we have plenty of space. Alright, so when I'm looking at 32, I'm looking at what can I multiply to get 32? Well, one easy thing is it's an even number, so I can always just divide it by 2. So 32 divided by 2 is 16. So I can do 2 times 16 and get 32. Well, 16 is an even number, so I know I can do 2 again. So 2 times 8 gives me 16. So 2 is a prime number because it can only be multiplied by 1 and itself to get the answer. So I can multiply 2 and 4 to get 8. And then I can multiply 2 and 2. So in this case, I've got 1, 2, 3, 4, 5, 2. So I can do 2 times 2 times 2 times 2 times 2 to get 32. And then let's look at the x cubed. How do I rewrite x cubed? That is x times x times x. So let's look at 12x squared. So that's 2 times 6 can get me 12, but 2 times 3 gets me 6. So I circle the bottom of all my little factor trees, and so 2 times 2 times 3 gets me 12. This is x squared, so I had to do x times x to get x squared. So then let's look at 40. It's even, so I can jump straight to dividing by 2's, but I could also know that if I do 5 times 8, that's 40. I can start there. So then 2 times 4 is 8, and then 2 times 2 is 4. So these are my prime factors. So I have 2 times 2 times 2 times 5, and in this case I only had one x. So now that we have our prime factors written out on lines, we've got to figure out what do they have in common. Well, so far they all have at least 1 2. They have 2 2's in common, and that's it. They don't have any more 2's in common. This one has a 3. Now the other ones have a 3. This one has a 5, but none of the other ones have a 5. So let's look at how many x's they have in common. This has 1x, this has 1x, and this has 1x. And that's it for the x's. So the greatest common factor for this trinomial is 2 times 2 times x, which is 2 times 2 is 4x. So you thought we were done, but we're not. That just means we're pulling a 4x to the outside. So what do I have left in this first term? I have 2 times 2 times 2, which is 8. So in this first term, I've got 8 left. And I've got x times x, which is x squared. And it was a plus sign in between. So plus. In this second term, I have a 3 and an x left. And it was a plus sign before the last term. And then in this last term, I've just got 2 times 5, which is 10. So this, the greatest common factor was 4x, but this is your answer because this is it factored out. So that's a lot. It'll be okay. Let's look at another example. So I've got 8p to the 5th power. Got negative 64p to the 4th power, and I've got an 8p cubed. And I'm actually going to go ahead and ignore that negative sign right now on that one. So let's start factoring these out. So it might help to come down here and do the numbers separately. So we got an 8, a 64, and an 8. So we got an 8, a 64, and an 8. So for the 8, we're only going to have to do it once, because we can use the same thing. So to multiply, what can we multiply to get 8? Well, 2 times 4. Well, what do we multiply to get 4? 2 times 2. And 2 is a prime factor, so that's where I stop. So that means for my 8s, I'm going to have 2 times 2 times 2 for both of them. So then let's look at factoring 64. If nothing else, you should see that it's an even number, and you could start with 2. Or what can I multiply and get 64? Well, that's 8 times 8. Well, that's going to be 2 times 4, and that's going to be 2 times 2, and that's going to be 2 times 4, and that's going to be 2 times 2. So you come back and you circle the numbers that didn't have a tree going from the bottom of them. So that's why I'm only circling the true 2's. This 4 has a tree going from it, so it's not a prime factor. So I have 1, 2, 3, 4, 5, 6 2's for 64. And then I'll go back and add the multiplication signs in between. So then let's do the letters. I feel the letters are the easiest part. It's p to the 5th power, so I write 5 p's. 1, 2, 3, 4, 5. And put a multiplication sign in between all of them. P to the 4th, that's 4 p's. P, 2, 3, 4. P to the 3rd, that's 3 p's. 1, 2, 3. Didn't need a multiplication sign there at the end. Alright, so now let's look through here and see how many they have in common. So they all have at least 1 2, so I highlighted 2 in each of them. They all have at least 2 2s, so I highlighted 2. Now they have 3 2s, and then I'm out of 2s on the first line. So all they have in common are 3 2s. So over somewhere to the side, I'm going to have a 2 times 2 times 2, which in this case works out to be 8. So I'm pulling an 8 out. And then let's look at how many p's they have in common. Well, they all have at least 1 p. This one has more, that one has another one, so they've all got 2 p's in them. When I look at this bottom one, it has 3, so they've all got 3 p's in them, but no more. They have 3 p's in common. So p times p times p is p cubed. So what they have in common is an 8p cubed. So what does that leave me in the first term? Well, I've used everything but these 2 p's. So p times p is p squared. Then it was a minus sign in my original problem, so that's why I ignored the negative, just because I'm going to come back and put it right there. And so in my second term, I had 2 times 2 times 2, which was an 8. And then it had 1 p left, so it had an 8p left. And then in my last term, I had a plus sign, and I don't have anything left. So I don't put anything. I actually I don't put a 0, I put a 1. Because 8p cubed divided by 8p cubed is 1, not nothing. So this is your final answer. Alright, so I'm going to start looking at this one. I have a 10r cubed, I have a 20r, and I have an 8. So 10, if I'm trying to factor that out, what can I multiply to get 10? Well, that is 2 and 5. And nothing else goes into 2 and 5, so I can come up here and I'm going to have a 2 times 5. So then I have 20r, so I'm looking at the 20. What can I factor out of a 20? Well, I know I can do 2 times 10, and then I know 10 factors to 2 and 5. So 20 is 2 times 2 times 5. And then I have an 8, and I know that is 2 times 4. And then to get 4, I do 2 times 2. So I just remember, pick the ones at the end of the tree. So that is 2 times 2 times 2. So then I'm done with this. This is just notes on the side, so you can erase it or just work it on a scrap sheet of paper. So now I need to come back and look at the letters. And this one I have r cubed. So I have r times r times r 3 times. This one I just have an r. And this one I don't have a variable. So let's go through here and highlight what they have in common. Well, they all have at least 1, 2 in common. These two have a 5, but this one doesn't, so I cannot highlight the 5. These two on the bottom have one more 2, but the top one doesn't, so I can't highlight another 2. And then looking at the letters, the top two have at least 1 R in common, but the bottom one doesn't have any R's. So I cannot factor out a variable. So in this case, the only thing that I can factor out is this 2. So I'm going to have a 2 on the outside. So in the first one, in the first term, that leaves me with a 5, and that was r cubed, r times r times r, and it was a minus sign. And the second one, I'm left with 2 times 5, which is 10, and an r. And the last one, I'm left with 2 times 2, which was 4. So if you were to multiply this back out, distributive property, 2 times 5 is 10, and that's an r cubed. 2 times a negative 10 is a negative 20r, and 2 times 4 is a positive 8. And that should be the answer that we started with, and indeed it is, so I did factor this correctly. So if I look at this one, do I really need to look at the prime factors of the numbers? Because what number do they all have in common? All of them have a negative 6. So I don't have to factor the numbers. I know I'm pulling out a negative 6. Because if there is a negative that I can pull out, I like to pull it out. So then really all I have to look at are the x's. This term has 1x. This term has 3 x's. And this term has 6. So what's the biggest number of x's they have in common? Well, sadly, they just got 1 x in common. So I can pull out a negative 6x. So that leaves me on the inside with negative 6x divided by negative 6x. That's a 1. Here, these are all going to turn to positive signs because I pulled a negative out. I have x times x, so that's x squared. And then here I have 1, 2, 3, 4, 5 x's left, so that is x to the 5th. So the last example I believe we have of factoring for notes today is, let's come over here and we'll look at factoring 8. 8 factors out to 2 and 4, and then 2 and 2. So I have 8m, and I'm going to have 2 times 2 times 2 times an m. And then I have 7. 7's already a prime number. So what I have with 7 is just 1 and 7. So 7 times, but I can factor that m squared out. And then I have a 10m cubed. So I'm going to look at factoring 10. So 10 I know is 2 and 5, and those are prime factors. So it's 2 times 5, and it's m cubed. So it's m times m times m. So I can start looking to see what they have in common. And in this case, they have no numbers in common because of this 7 being prime. If they have an m, they all have at least one m. So in this case, what I'm pulling out, the prime factor, is just an m. So I pull out an m. So in the first term, I'm left with 8, because 2 times 2 times 2 is 8. It was a plus sign in between. So here I'm left with a 7 and an m in the second term. Then it was a minus sign. And 2 times 5 was 10. And I have m squared left. And so this would be how I factor out a greatest common factor for this problem.